Welcome to the last section in Chapter 1, and that is Section 1.5. And we are still trying to find solutions to equations. And we begin with lots of square roots or radicals. And realize that if we are trying to get rid of a squared, we take the square root. If we try to get rid of the square root, we square it. So what we're going to do here is we're going to square both sides. So we get 5x plus 6 equals 36. Then it becomes a relatively simple problem. Subtract 6 from both sides and divide both sides by 5 so that x equals 6. We do need to check to make sure that this final answer does work. 5 times 6 is 30. 30 plus 6 is 36. Square root of 36 is 6. X equals 8 root x. Now, much like when we use the square root method, we have to get something squared all by itself. Same thing applies here. We have to get the square root all by itself. So the first thing we're going to do is divide both sides by 8. And so we get x over 8. Now we can square both sides and we get x equals x squared over 64 because x over 8, the quantity squared, is x squared over 64. And then what we want to do is we want to solve for x at this point. Common denominator is 64. Multiply everything through by 64. And use any one of the methods that we've looked at in the past. I'm going to get everything to one side and set it equal to 0. X squared minus 64x equals 0. I notice that x can factor, leaving x minus 64. So that means either x is equal to 0 or x minus 64 equals 0, which means x would equal 64. Once again, do the check into the original and you will find that both of these are correct. Number 3, square root of x squared minus 3x plus 64 equals x plus 5. Now here we have the square root all by itself, so we can square both sides. But realize that when you square this side, that's going to require you to FOIL this. It's not x squared plus 25. It's the quantity x plus 5 squared. So squaring this side, we get x squared minus 3x plus 64. Squaring this side, we get x squared plus 10x plus 25. Subtract x squared from both sides. Subtract 10x from both sides. Subtract 64 from both sides. And then subtract or divide both sides by negative 13 and x equals 3. And once again, it doesn't take much to check this. 3 squared is 9. 9 minus 9 is 0. 0 plus 64, square root of 64 is 8. And 3 plus 5 is 8, so it does work. Example number 4. Square root of 2x plus 5 minus the square root of x minus 2 equals 3. Now unfortunately this is going to require quite a bit of work, mainly because we have 2 square roots. But the same rule applies. Get one of those square roots all by itself. So I'm going to add the square root of x plus minus 2 to both sides. Now I'm going to square both sides. Now when I square this side, that's pretty simple. 2x plus 5. But when we have to square this, 3 plus the square root of x minus 2, the quantity squared, you have to FOIL it out, just like any other situation. And what that ends up being is 9 plus 6 times the square root of x minus 2 plus x minus 2. Now the problem is that we still have this square root. We're going to have to do this process all over again to get that square root all by itself. So the first thing I'm going to do is to add the 9 and the minus 2. So that will be 7 plus 6 square root of x minus 2 plus x. Subtract x from both sides. Subtract 7 from both sides. Divide everything through by 6. Now take the square root, or the square of both sides, because now we've got the square root all by itself. So squaring this, once again, it's going to require factoring or foiling. And so this whole quantity squared becomes 1/36 x squared. Let's see. Minus 1/9 x plus 1/9 equals x minus 2. Let's get rid of the fractions by multiplying through everything by 36. And so this becomes x squared minus 4x plus 4 equals 36x minus 72. And then solve from here. We have to get everything to one side and set it equal to 0. X squared minus 40x plus 4 equals negative 72. And then add 72 to both sides. X squared minus 40x plus 76 equals 0. And then finally we get to factor x minus, let's see, what are the values here? X minus 2 and x minus 38. So x minus 2 might equal 0, or x equals 2, and x minus 38 might equal 0, or x equals 38. And if you check both of these in the original problem, they will both check. Example number 5. 5 appears a little bit different. It's 5x minus 4, the quantity raised to the 1/2 power equals 4. That simply means the square root of 5x minus 4 equals 4. And we know how to do this. Square both sides. 5x minus 4 equals 16. 5x adding 4 equals 20. And then dividing both sides by 5 gets x equals 4. Number 6 is very similar. We can rewrite it as the square root of x squared minus 1 equals 6. Square both sides. X squared minus 1 equals 36. Add 1 to both sides. X squared equals 37. And then take the square root of both sides. X equals plus or minus the square root of 37. Realize when we do the check here, this will turn positive, positive 37. In both cases, 37 minus 1 is 36, and the square root of 36 is 6. So it all does work out. And we are now ready for example number 7. For a cone, the formula r equals the square root of 3v over pi h describes the relationship between the radius r, the volume v, and the height h. So we are asked to find the volume. We want to find v if the radius is 7 inches, the cone is 8 inches high, and we get to use 3.14 as an approximation for pi and rounding to the nearest tenth. So first thing, square both sides. So we get 3V over pi 8 equals 49. Multiply both sides by pi 8, or 8 pi. So 49 times 8, well, you know, it doesn't really matter because we're going to be plugging all this into our calculator here shortly. So 3V equals 49 times 8 pi. And so dividing both sides by 3, we get 49 times 8 pi, all divided by 3. And we're allowed to use 3.14 as an approximation for pi. And so this equals approximately 52.1 cubic inches. And the final example for this particular video. The maximum number of volts E that can be placed across a resistor is given by the formula E equals the square root of PR, where P is the number of watts, R is the resistance in ohms, and E is in volts. So we need to solve this equation for R. So first thing, square both sides. And then divide by P. So R will equal E squared over P. Then it says, use this result to determine the resistance if P is 1/8 and E is 12. So we get 12, and P is 1/8, which will equal 144 over 1/8, which equals 1152, and R is the resistance, R is in ohms, and so final answer is 1152 ohms.